Hello and welcome to this section of the Algebra Tutor. In this section we're going to continue talking about polynomials, and specifically we're going to talk about how to add and subtract polynomials. And so it's very, very important to understand when you can add things together in algebra and when you can't. And when I say add them, I also mean subtract them. So anytime you can add them or subtract them is something that you're going to have to master, because you're going to constantly be dealing with situations where you're simplifying expressions, so you'll have to know when you can add terms together. And in these polynomials, when you're adding one polynomial to another polynomial, how you can actually combine the terms together and make it simpler. That's what you're really trying to do when you add things together, is to add it together and to simplify it. There's one rule that you need to understand in order to be able to know when to add and subtract polynomials, how to combine the terms together properly. And a lot of students think it's this mystical thing and it gets very confusing, but there's only one rule that we're going to learn in this section, and it's so easy once you understand that. So listen carefully. The only way you can add or subtract terms from polynomial to polynomial, or for expression to expression, is if you have like terms. The only terms that you can combine together and add or subtract, they have to be similar. Let me show you what I mean by that. It's much easier to give an example than just to talk about it. So what if I have, forget about polynomials now for a second, let's just say I have 3y, I'm going to put a comma here, and 4y. And let me ask yourself, or let me ask you, are these terms like terms or not? Are they similar, in other words? The answer is yes. These guys are basically what we call like terms, right? And the reason that they're called like terms is because they both have y's here, okay? So this is 3y's, 3 times y, right? 3 times the value of what y is. And this is 4 times y, 4 times the value of whatever y is. But in both cases, I'm talking about something multiplied by y, and here I'm talking about something multiplied by y. So ultimately, I'm kind of talking about, I'm dealing with y. I'm not dealing with y squared. I'm not dealing with y cubed. I'm not dealing with, you know, y times y cubed or y times y squared. I'm only dealing with y. So these things, even though they have different numbers in the front, they're similar, right? So if I wanted to add them together, for whatever reason, so if I wanted to add these two terms together, the sum would be, what do you think it would be? Well, 4 plus 3 is 7, and I'm still talking about y, so I have to keep my y along for the ride. So if I were to add these two things together, I would get 7y. So when you start thinking in terms of algebra, you need to start thinking in terms of when you can combine things together if you're trying to add them together, right? So here, this is a like term with this because I'm both talking about whatever the value of y is or whatever the idea of what y is, right? What if I ask you, as a similar example, what if I have 3 apples as one term and 4 apples? Right? So obviously I'm drawing a comparison because I have 3 and 4, but let's just say I have 3 apples and 4 apples, and I asked you how do I add them together. Then it would be easy for anybody watching this video to say you have 7 apples, right? So I would say the sum is 7. 7 what? 7 apples. It makes sense to us when we talk about apples because we know that apples are this nice, delicious thing that we can eat. And if I have a bucket of 3 apples over here and a bucket of 4 apples over here, it's easy. We understand that we can add those together and we can get 7 apples. But when you think about it, the only way that you're really allowed to add these apples together is because you're talking about apples in one bucket and apples in the other bucket, right? What if I had apples in one bucket, like 3 apples or something, in the other bucket I had, you know, ping pong balls, right? So apples and ping pong balls, right? I could add them together. I could add the numbers, but what would it mean? I would just be getting the total number of objects, I guess. That kind of makes sense, but it doesn't really make sense because in real life, it only really makes sense to add things that are similar. If you're trying to get an answer that is representative of the whole unit, it only really makes sense if you're trying to add like things together. In terms of algebra, it's the same way. It only makes sense if you're trying to add things that are similar to one another. So you can add apples to apples, and yes, in real life you can add apples to oranges, and I guess it would represent the total amount of fruit you have, but in terms of algebra, you want to group things into these like buckets in order to be able to add them together. That's why we're able to add 3y and 4y, because basically they look the same. The variables match. They look exactly the same in both cases. So knowing this, what if I give you a term, 3x and 3y, two terms, 3x and 3y, and I say, hey, add these together. Well, you're going to immediately look at this and realize that these are not the same. Yes, I have 3, and yes, I have 3. But this is an x and this is a y. These are different. This could be water buffaloes, and this could be, skyscrapers. I mean, I could add them and get 6, total sum of everything, but I don't want to do that. I can only really add things together in algebra that match. So this is really unlike terms. So, a lot of times in algebra you start learning about like and unlike terms, and the reason is because you can only add things together if they're like, if they're similar to one another. So if your exam or your teacher says something like, circle the terms that are similar, circle the like terms, you're only going to circle things where the variables match exactly like they did up here. X and Y don't match at all, so you're not similar terms, they're not like terms, and because of that you can't add them. If you had a plus sign between here, then you'd have to leave it like that. You couldn't actually do the addition in terms of algebra. All right, so let's do another example. What if we had 3 terms, 3x cubed, 4x cubed, 6x cubed. Are these like terms or not? Well, here I'm talking about x cubes. Here I'm talking about x cubes. Here I'm also talking about x cubes. So these are like terms. That means that this might as well be watermelons, watermelons, and watermelons. Now everything has to match. The x has to match, and the exponent has to match for them to be like terms. If one of these exponents were different, then it wouldn't be like the other ones. Everything exactly has to match. So if I wanted to write the sum, 6 plus 4 is 10, 10 plus 3 is 13. 13 what? You're still talking about x cubes. So whenever you add things together in algebra that are like terms, you add the numbers together like usual, and you have to carry along whatever it is you were talking about. Because this is like 3 pencils, this is like 4 more pencils, and this is like 6 more pencils. So that's 13 pencils. If you don't put the x cubed, then it's not referencing what we were adding together to begin with. All right, let's go do another one. Let's say we have negative 5x cubed times y squared. Next term, 13x cubed y squared. Final term, actually that's the only 2 terms I have. Are these 2 terms like terms or not? Well, there's numbers in front, obviously. Here I have x cubed y squared. Here I have x cubed y squared. Everything matches exactly. The x matches the x, the y matches the y. The cube on the x matches the cube on the x. The square on the y matches the square on the y. Because everything matches exactly, these are like terms. If anything were different, they wouldn't be like. If I cover up this and make it y to the first power, then these are not like terms. Because everything has to match, everything after the number. Right? So because these are like terms, I can take negative 5 plus 13, which is the same as 13 minus 5, and the sum is 8x cubed y squared. And you have to carry along whatever it was we were talking about. We were adding up, bulldozers and then more bulldozers. So our answer is going to be in terms of bulldozers. I'm kind of using analogies here to tell you that when you see these things here, you got to start looking at your grouping. This is something, this is something. I have to have that something in the answer because that's what I was talking about the whole time. So let me go ahead and erase the board, and we'll continue to work some more of these problems to drill this in. All right, what if I have negative x squared times y? The next term is x times y, and the next term is 3 times x times y squared. And the question is, are these like terms or unlike terms? Well, if you're not experienced in this, you might say yes, because you have an x here, x and x, you have a y, and a y. But hopefully you've realized that that's not true, because the exponents are all different. Here I have x squared, x, and x. Here I have y, y. These match, but this one's different. So if I'm going to say that all of them are like terms to one another, then they all have to match exactly. They all have to have the same variable and the same exponent everywhere, and of course these don't match, so these are unlike terms. Which means if I were trying to add these together, I could not do it. If you try to put plus signs here and plus sign here, then you just literally have to leave it like that on your paper because there's no way to add these things because they're unlike. They're nothing like one another. So in terms of algebra, you just can't do anything if it's like that. What if we have something like, now let's actually get into the actual addition, negative 8t squared minus 4t squared. So here is a term, here is a term. This is a binomial, right? Which is a polynomial with two terms, right? So let's say we want to combine these guys together, all right? Or see if we can combine these guys together. Well, do I have like terms? T squared, they match. I do have like terms, so now I can add or subtract the numbers that are in front. So negative 8 minus 4 is negative 12, and you have to carry along whatever it is you were talking about. So it's negative 12t squared. All right. What if I had 18 x to the 5th power times y squared minus 11 x to the 5th power y squared? Can I subtract these? Well, you look at this and you say, can I subtract them? Well, I have x to the 5 y squared, x to the 5 y squared. They match. These are like terms. So I can take 18 minus 11 and I will get 7. 7 what? X to the 5 y squared. It just comes along for the ride because this is like peanuts, subtracting some more peanuts. I'm going to get however many peanuts left. Everything matches. Everything has to be carried along. So this is the answer, 7x to the 5th y squared. Okay? Switch colors. Let's say we have 3 times r times s times t plus 4 times r times s times t plus 7 times r times s times t. Can I add these together? Well, RST matches RST matches RST. The coefficient, the variables and the exponents match for every term that I have. So these are all like terms. 3 plus 4 is 7. 7 plus 7 is 14. 14 what? RST, because that's what I'm talking about. That's what the whole problem was about. That's what I was adding together to begin with. All right, so let's go ahead and do a different thing. Let's say we have 3x squared minus 4x squared plus 10x squared. And the question is, simplify this expression as much as you can. Well, you know you're going to be able to combine these in the end because I have x squared and x squared, but what about this guy? This is 3x raised to the 2nd power, but we've learned that anytime we have that, we apply the exponent to both places. So 3 squared is going to give me 9, x squared is going to be x squared, and then I have minus 4x squared plus 10x squared. And I look at these and I say to myself, are these like terms? X squared, x squared, x squared. Everything matches, so I can just add the numbers together. 10 plus 9 is 19. 19 minus 4 is 15, so I'm going to have 15. 15 what? I'm talking about x squared, so 15x squared. So that's the final answer there. It's very simple. It's like a matching game, actually. Once it looks complicated when you first start algebra. All the stuff looks complicated, but then you start realizing, like, oh, it's easy. All I'm doing is looking to see what matches, and when it does, I can add them or subtract them. All right, so let's have 5x squared y squared plus 2 times x times y squared minus 3x squared times y squared. So some of these problems are getting to look a little bit weird to force you to kind of use some of the knowledge that you've used before. We know here that when we have a parenthesis with things inside of it and the exponent is outside, that applies to both, we just apply the exponent to both cases. So what we're going to have is 5x squared y squared, this just stays along for the ride, plus 2. X, with the exponent applied, is x squared. Y squared, this because y also has the exponent applied. And then when we get to this last term, it's a little silly that it was grouped like this to begin with. 3x squared times y squared. You really don't need these parentheses. A lot of times on tests, they'll give you a parenthesis, but it doesn't really matter because there's no exponent applied out here. There's no number out front that needs to be multiplied in or anything. So it's really just sitting there for no real purpose. There's nothing added together inside, so I can just take them away. And now I look and I say, can I simplify what I have left? Do I have any like terms? Well, I have x squared, y squared. Here I have x squared, y squared. Here I have x squared, y squared. Everything matches everywhere. The exponents matches, the letters match. So I can add all of these together. 5 plus 2 is 7. 7 minus 3 is 4. 4 what? 4x squared, y squared, because whatever it is I'm calculating has to carry along through to my final answer. All right, let's say we have something like 3x plus 7 wrapped up in a parentheses like this, plus 4x minus 3. And we're trying to simplify this to try to see how we can simplify, how we can add these together. At first, you're looking at this and saying, well, can I add anything inside of here? I can't really add these. These are different because I have an x here, but I don't have an x there. I have an x here and I don't have an x there, so I can't really do anything inside the parentheses. But then you realize these parentheses really are here mostly in this problem to confuse you, because there's no exponent out here that needs to be applied in, or here. There's no number out here that would need to be distributed in. So they're sitting there with parentheses, but because there's nothing really applied, you know, usually when you have parentheses, you have it there usually because you've got something outside of it that needs to apply to everything inside, like a number outside that needs to be distributed in, or an exponent that needs to be applied to everything. But neither of these are the case. So this is the same thing as just taking them away. 3x plus 7 plus 4x minus 3. You just kind of take them away. They aren't really needed. So then you look and you see if you have any like terms. Well, 3x, 4x. The x's match, the exponents match. These are like terms. 3 plus 4 is 7. 7 what? 7x. And these are like terms. Of course, we call these numbers, right? 7 minus 3 is 4. So the final answer is going to be 7x plus 4. And really the rest of the problems in this section is just giving practice. There's nothing harder to come. There's no more rules to introduce. It's just getting some practice. Let's say we have 3x squared minus 3x minus 2 plus 3x squared plus 4x minus 3. And we're trying to simplify this to add these together. Well, I have a trinomial here, 3 terms, and I have another trinomial here, 3 terms, and they're each wrapped in parentheses. But again, I notice I don't have any numbers out here that need to be distributed in for either one, or exponents. I can't do anything inside because I have an x squared. It does not match the x because they're different. The exponents don't match, and of course it doesn't match this. So I can't really add anything inside of any of these because they're all unlike terms inside. But since there's nothing applied outside of any of these parentheses, then basically they don't really serve a real function in this problem other than to try to confuse you. So just strip them away. So we just write everything down. Now everything's on a level playing field and we try to identify like terms. So we notice right here we have a 3x squared, I'll put a squiggly line under it, and we have another 3x squared over here. The x squared matches this x squared, so these are like terms. 3 plus 3 is 6. 6 what? 6x squared, because that's what I'm basically dealing with. Now we look for other like terms. Here I have a negative 3x, or a 3x with a negative sign in front. Here I have a 4x. These guys are like terms because I have x and I have x, so I can combine them together. So I'm going to have negative 3 plus 1 or plus 4 from over there, which is the same thing as 4 minus 3, is 1. And 1 what? 1x. So I'm going to put 1x there. I'm going to put that in purple so to kind of match the purple that I have up there. And then my numbers are always like terms, of course, if they're just straight numbers. So negative 2 minus 3, you should remember from adding and subtracting numbers, that's negative 5. So that matches in black. So here's the final answer. The 6x squared comes from combining the red terms. The 1x comes from combining the purple terms, and the numbers come from combining the black terms. So 6x squared plus x minus 5. And we're going to do more problems, but the basic idea is this. There's nothing more complicated than this. When you have large expressions with adding and subtraction going on, when you're trying to simplify it, you're really just trying to look for things that match. It's like playing, a memory game or something like that, where you're trying to find things that match. So when they match, they have to totally match the exponents and the variables. And when they do, you can add the numbers up. All right, what if we have 2 times b squared plus 3b minus 5 minus 2b squared minus 4b minus 9. Now here we have, again, 2 polynomials. These are trinomials. One of them is here, and from it I'm subtracting another one, which is here. So this is a trinomial, this is a trinomial. Notice I can't do anything inside because none of these terms match. These terms don't match. So it looks like it's a carbon copy of the previous problem. The first set of parentheses, there's nothing out in front, there's no exponent, so I really don't need the parentheses, so I'll just strip it out. 2b squared plus 3b minus 5. Now at first glance you might look at the second set and think, well, the same thing's happening here, because there's no number out front and there's no exponent, but you have to be careful, right? You have to be careful. You have a minus sign out here. Anytime you see a minus sign out in front of anything, including parentheses, you really need to read it as -1 multiplied by everything here. So this -1 is kind of invisible and it's sitting out in front of this parenthesis. What do we do with numbers if they're sitting out front of a parenthesis? We have to distribute them into every term inside. So a lot of students will gloss over that and not even realize that, but this -1 has to apply to this term, and then it also has to apply to this term, and then it also has to apply to this term, because it's like -1 multiplied to everything inside of there. So you have to make sure to do that. So in fact, the parentheses actually do serve a purpose here to force you to do that. So let me ask you, what's -1 times 2b squared? It's going to be -2b squared, right? What is -1 times -4b? It's positive 4b. What's -1 times -9? It's positive 9. So you notice how this negative sign has basically flipped the sign of everything inside that we had. And that was very important to do. If you ignored that, you're going to get different signs everywhere, and then your whole answer is going to be completely wrong. So just be careful about that. So now we do the same thing. We look for like terms. I have a 2b squared here. I have a -2b squared there. Notice what's going on there is these two basically subtract out. 2b squared minus 2b squared. So they match, right? The b squareds match, so I subtract the numbers. 2 minus 2 is 0. So really, they disappear from the problem. You don't even see them in the answer because they subtract out to 0. So we look for more like terms. Here I have 3b, here I have a 4b. The b's match, so I can add, so that's going to give me 7b, right? And then I look, let me change colors just to make it clear. I'll look over here, I have -5, positive 9, right? So how do I do that? -5 plus 9 is the same as 9 minus 5, which is 4, plus 4. 7b plus 4 is that answer. And really, it was extremely simple. The only thing we need to make sure is when you have -1 out in front, you have to make sure and apply it to everything inside. And that's something you just have to get used to. Now, let's do something a little different. It's the same idea, but just slightly different than any of the other problems we've had before. 2 parentheses x plus 3 plus 3 parentheses x plus 3. And the question is simplify this. Complete the addition and simplify this. So you know that since you have a number out here, you have to apply it to everything inside. This number applies to everything inside over here. This is basically following the rules that we have done for all of these problems. So applying this one, 2 times x is 2x. 2 times 3 is 6. Over here, 3 times x is 3x. 3 times 3 is 9. So now I'm back to where all the other problems have been. I want to try to combine like terms. I notice I have a 2x and I have a 3x. The x matches, the exponents match, so I can add these. 2 plus 3 is 5x, because I have to carry x along. That's what I'm talking about. Finally, I just add my numbers. 6 plus 9 is 15. And then I have 5x plus 15. There's nothing more I can do here. I can't add these anymore because I have x's here and I don't have anything over here. So this is like bulldozers and cotton candy. I just can't really add them. It doesn't make sense to add them or to group them together, so I leave them like that. All right, just a couple of more problems here in this section. What if we have -8 times x minus y plus 11 times x minus y? All right, so it's the same kind of thing. We want to simplify it. We want to add everything together. We can, but we have a -8 out in front of this guy. So we know we have to apply the -8 into each term. -8 times x is -8x. What's -8 times -y? Well, negative times negative gives you positive, so you got to make sure and do that. And you're going to have 8y. Okay? Over here, you're going to have 11 times x, which is going to give you 11x. You're going to have 11 times -y, which is going to be -11y. because negative times positive gives you negative. So you have to make sure and keep track of those signs. Now we look for like terms. I have negative 8x, right? And I have over here 11x. So the x's match, the exponents match here, so these are like terms. So what is negative 8 plus 11? It's the same thing as 11 minus 8, which is 3. So 3x. And I have to carry the x down because that's what I'm talking about. Now the only two terms left is this y term and this y term. These are like terms because I have y matching with y, so I can add these together. What is 8 minus 11? I think you'd agree, if we talked about it enough and done enough of these problems before, that 8 minus 11 is going to give you negative 3y. So that's why I have a negative there. Basically, you subtract them. 11 minus 8 gives you 3. The negative sign comes from the bigger number, right? And then y comes along for the ride because that's what I'm subtracting. So that's the final answer for this problem. 3x minus 3y. Now here's the last problem of the day, and it's going to be a little bit longer just so I can give you the ultimate practice. What if we have 3y, x, y plus y, minus 2y squared, x minus 4 plus y, plus 2y cubed plus y squared. And that's the problem. Okay, it's a pretty long problem, but really you start to, at this point in your learning of algebra, you start to group things and start to see, okay, I've got this to deal with, and then after that I've got this to deal with, and then after that I've got this to deal with. So instead of looking at this whole problem and giving up and saying I have no idea, you just tackle it one thing at a time. This 3y is sitting out in front of this parenthesis, so I need to distribute the whole thing, 3y, into each of these terms. That's how we've been doing everything, right? So 3y times xy is going to give you 3 times x times y squared. And make sure you understand that, because the 3 times the 1 in here just gives you 3. The x just comes in from what's in there, and the y times y is going to give you y squared. So that's straightforward. It's just basically multiplying those exponents. Anytime you multiply exponents that have the same base like this, y times y, then you can just add the exponents. So that's what we did there. 3y times y over here is going to give me 3y squared, because y times y gives me y squared. So I'm actually done with this part for now. Now you need to work for the middle part. Here I have a negative 2y. I have a negative, don't forget about the negative sign, negative 2y. The whole thing gets distributed in to each of these three terms. You have to make sure and distribute the negative in with the actual 2y squared. So I have negative 2y squared that's going to apply in. So what is negative 2y squared times x? You're going to get negative, because negative times positive gives you negative, 2 times x times y squared. Now, you might be tempted to say 2 times y squared times x, and I flip it around when I write it because I want it to match what I already have, because I know later on I'm going to be combining these terms. And I know that when I multiply things, I can flip the order. So even though it's written like 2y squared times x, I know that I can flip that around. You can do it however you like to keep track of it. It's fine either way. Now I have negative 2y squared times negative 4. Negative times negative gives me positive. 2 times 4 gives me 8. And I still have a y squared from here. So that's there. And then negative 2y squared times positive y is going to give me a negative 2 times or I should say 2 times y squared times y is going to give me 2 times y cubed, because I add the exponents. I'm multiplying these together so I can add the exponents. 2 plus 1 is 3. Now I'm going to continue on the next line to what I get over here. So what I'm going to have is plus 2 times y cubed is just simply 2y cubed. 2 times y squared is just 2y squared. So this is everything. I'm going to draw a little line here to make sure I keep track of things. Now, I need to go ahead and start combining terms. And the first thing I notice is that I have a negative, when you scan through here, there's other things you might notice first, but the first thing I noticed is I have a negative 2y squared. Here I have a positive 2y squared. So, I'm sorry, I'm saying y squared. This is y cubed here and y cubed here. So this is a like term with this, and I have negative 2y cubes and positive 2y cubes. And so I basically can add them together, and since 2 minus 2 is 0, these guys, let me switch colors, these guys basically disappear. They don't even show up in the final answer because I'm adding them together. 2 minus 2 gives me 0. I can do that because these are like terms, right? So now I look for any other like terms. Here I have an x times y squared, so I'll put a little underline there. Here I have an x times y squared, so I'll put a little underline there. This doesn't match anything here, it doesn't match anything here, and it doesn't match anything here. Everything has to match in order for them to be a like term. So now I can subtract. 3 minus 2 gives me 1. 1x times y squared. Don't forget there's an implied 1 out front, so I don't need to really write that 1. All right, and then I have, let me switch colors here. I have a y squared here, 3 times y squared. I have an 8 times y squared here, and I have a 2 times y squared here. So this y squared matches this one, which also matches this one. So all three of these are like terms, so I can add them. 8 plus 2 is 10, plus 3 is 13. Times what? Times y squared. Basically it has to match whatever I've been adding up. So it looked super complicated in the beginning, but we quickly just multiplied through, being careful with our signs, and then we tried to combine terms. We noticed that this one just basically subtracted with that one to be 0, and then these guys matched, so we made that subtraction there. These guys matched, so we did that addition there, and we just carry everything through. So x times y squared times 13y squared. And that's the final answer. And that concludes the section on adding and subtracting polynomials. We could do a ton of other problems, give you more practice, but basically this illustrates the idea. Anytime in algebra, when you're adding large, amounts of terms together, and you're trying to simplify them, basically what you're doing is looking for those like terms. You're looking for everything to match. And if they don't match, if one of the exponents is off, or if one of the variables is off, they don't match. You can't do anything with them. Everything has to match. And whenever you do the addition, whatever it was you were adding together has to come along for the ride. So it's like adding, adding donkeys to donkeys. You got to end up with donkeys. So you have to carry it along because it's kind of referencing what you were adding together to begin with. So try to think of it that way. I'm trying to give you ways to think about it that will make sense to you. So make sure you can do these problems. Make sure that you can do extra problems either in the companion worksheets or in the textbook. Make sure you understand these really well. And then move on with me to the next few sections where we are going to learn how to multiply and how to divide polynomials.